now looking at target 3C, which is all about theorems involving circles. Our 3C.1 master learning objective is identify properties of central angles and inscribed angles. So we're going to look at different sections where we're looking at different properties, of circles. Erase that. Okay, so the first thing we're going to look at is some vocabulary. So central angle, we've already kind of started looking at central angles when we were talking about the sector area and the arc length. Right, so a central angle is so a central angle is an angle with the vertex at the center of a circle. That's what it's called, a central angle. The one thing, it is made up of radii. Okay, so this is my central angle here, right? Again, we've already kind of looked at those when we were looking at sector area and arc length. A minor arc. When we look at arcs, we should know what an arc is. Right, it's a portion of the circle. The circumference of a circle. Wow, I can't spell. Of a circle. That is less than 180 degrees. Okay, so this would be my minor arc. It's less than 180 degrees, or another way of thinking about it is it's less than half the circle. Okay? So then a major arc is a portion of the circumference of a circle. I really can't spell today. That is greater than 180 degrees. So that would be this arc here. We will call a major arc. Okay, so if you notice, the minor arc and the major arc have the same central angle. It's just how you get between them. And then we have a semicircle. And a semicircle is exactly half of the circumference of a circle. Right, the word semi means half. Okay. Alright. Then we're going to look at chords and inscribed angles. Those are kind of the new things. A chord is a line, or a segment, really, we should say. Connecting any 2 points on a circle. So if I have a point here and a point here, this line here is a chord. There's a point on the circle, there's a point on the circle. This is a chord. So there's an infinite amount of chords you could make in a circle. Okay. So just as long as there's 2 points. The diameter of a circle, it does have 2 points on the circle. It is a chord. It's just a special chord that also goes through the center. Okay, so the diameter can be a chord as well. Then we have what we call an inscribed angle. And your inscribed angle is simply an angle with vertex on the circle. And like we said, our central angle is made up of radii. It is made up of chords. So if you have 2 chords, right? Here's a chord, here's my chord. Between them is your angle. And then again, this minor arc we'll often also call our intersected arc. It gets cut by those 2 lines. All right, so what are we going to do with all this vocabulary? Well, we have a lot of rules that we're going to learn. Our first rule, or our first theorem, says the measure of a minor arc is defined to be the measure of its central angle. The measure of a major arc is defined as the difference between 360 and the measure of its associated minor arc. We'll get to that later. So looking at example 1, we're finding the measure of this angle. What this theorem is telling us is the measure of the arc. And measure of an arc, remember, is angle measure, equals the measure of the central angle. Okay. So I know the measure of my arc is 120 equals, work today, x is the central angle. Look, I'm done. Okay, so they are the same. That central angle and that arc are the same measurement. Example 2, same thing the other way. Okay, so it's still using the Now it works. Okay, hold on. The measure of the arc is equal to the measure of the central angle. My arc here is x, right? I don't know what it is. My central angle is 123 degrees. Our last problem, this is supposed to go with this. It didn't get moved to the next line, I guess. So we are finding the arc measure of CFD. So that's what it wants us to find. So that means I need to know all of these angle measurements. Okay. We'll start with this one. This is a line, meaning this whole thing is 180 degrees. So to find right here, right, I'm going to do 180 minus 135 equals 45 degrees. The next thing I know is if this is 45 degrees, then this is 45 degrees, because these are vertical angles. Okay? Remember those angles that are use the same lines, are the same measurement. That's something we learned last year. So now, I should be able to find this whole angle by adding everything up. I have 81 plus 45 plus 135 plus 45 equals, that's 180, so that's going to be 261, 306 degrees. So that means the measure of arc CFT also equals 306 degrees, because the measure of this angle is the same as the measure of that arc. Okay, so sometimes we have to just add everything up together. All right, go ahead and look at your next page. Our second theorem, if an angle is inscribed in a circle, that is right, if an angle is inscribed in a circle, then its measure is half the intercepted arc. So what are we saying here? That the measure of the inscribed angle equals 1/2 the measure of the arc. Okay, so there's a little more figuring out to do with these ones. So let's look at example 4. I'm finding the arc BC, so I'm going to put X there. So the measure of the inscribed equals 1/2 the measure of the arc. I know my inscribed angle is 38 degrees. Instead of dividing by 1/2, I find it easier just to multiply by 2, right? 1/2 times 2 is 1. Those go away. So X equals 76 degrees. Same type of thing for example 5. I'm finding angle BAC. Again, the measure of the inscribed angle is equal to 1/2 the measure of the arc. X is my inscribed angle. 1/2 times my arc is 160. 1/2 times 160 is 80 degrees. Always check your work. Your angle, or you can kind of see your angle is smaller than your arc. So if you're getting a bigger number, you probably flip-flopped what you went where. Okay, so be careful with that. All right, example 6. We want to find this. All right, for example 6, we are finding this arc here. It's a little confusing because we have lots of things. So I want to find what angle goes with this arc. So I look at my starting points and I look at these lines. Okay. So that's my angle, but I don't know that angle either. So you might have to, again, use other things that we've already learned. This is a triangle. So with that, I know a triangle adds up to 180 degrees. So y plus 49 plus 70 equals 180. 119 equals 180. Y equals 61 degrees. So now I know that angle so now I can use that angle to find just 60 degrees to find x by using again the measure of the inscribed angle equals 1/2 times the measure of the arc. I know my angle is 61 degrees. My arc is my x. I'm going to multiply both sides by 2. 2 times 61 is 122 degrees equals x. Okay, so again, with a lot of these inscribed angles, central angle problems, you have to add things, subtract things. 360, 180, all of those types of things come into play. All right, let's look at our last one. And we are finding this arc. If you notice, I only have this piece of it. So this one is probably the most difficult type of problem you will see. We're going to kind of break it down into lots of different pieces here. So I can find the measure of this arc here with using this 65. Okay. So 65 equals 1/2 times that blue arc times 2 times 2. 130 degrees equals the blue arc. I'm going to use the 119. To find this whole green arc. So 119 times 1/2 equals 1/2 times the green arc. Now I'm going to multiply both sides by 2. So the green arc equals 222.38. Okay. Now from that 238, I'm going to take away that 168 degrees. And we get 90. So just this section right here is 90 degrees. Then, right, if you look at where your blue arc is, I'm going to take away 90 from 130 degrees. And I get this section right here is 40 degrees. And that is what we wanted. Okay. So this would be the most difficult type of problem you would see. I'll tell you, this probably would not be a problem on a test. It'd be more a challenge homework problem. All right, our last theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if we look here, I have A to C to B goes over this. And if I start at A and go to D and then go to B, it also covers that. So what is that? This theorem is telling us angle C and angle D are congruent. Okay. Because it's the same arc, so therefore they're going to have the same measure. So looking at example 8, identify congruent angles. Same type of thing. I have EFD and EPD. Right? They both cover this. So angle F is congruent to angle P. I still have some more here I have FEP and FDP, right, both cover this angle, so I can also say angle FED is congruent to angle FDP. And I think that's it for those. So sometimes you'll have more than one set of angles that can be congruent. There might be another one in there, but I'm not too worried about it. Make sure you can identify at least one set of congruent angles. Alright, looking at example 9, our last one. This angle covers this arc. This angle covers this arc. Thus, those angles are congruent. So we have 2x plus 13 equals 3x. We're going to subtract 2x from both sides. So x equals 13. Okay. Alright, that is it. This video is a little bit longer, but I will see you guys tomorrow.